are not the same. You don't pay that much attention to this, so you might sort of forget that these are not the same. Okay? So here, let's say this one is F, and this one is G. So these are real, but my point is that these are really, really super different functions. And what I mean by super different is, what do we mean by functions are the same or different? Shh, guys. What do we mean by functions are the same or different? I just mean, obviously every function is different from every other function, so what am I talking about? Super different, what does that mean? I just mean, basically I'm talking about how quickly a function grows. Now that's not obviously the only thing you care about when you're talking about a function, but that's a kind of natural thing to think about. So everybody knows what this function, shh, guys. If we, okay, so actually, we're recording this class, and if there's too much noise, we'll have to take some what do they say? What do they say? What do the police say? We're going to have to take some certain kind of measures. What's that? What do they say? We have to take some, I don't know, extra measures. So, anyway, so what is this? Everybody knows what that looks like, right? That's just a parabola, right? Right? Everybody knows that. And, you might say, oh, that grows fast, because when x is equal to, 2, it's 4. When x is equal to 8, it's 64. When x is equal to 10, it's 100, right? The value of the function is 100. When x is equal to 100, what do you get? 100 squared is what? 10,000, right? So you say, oh, that grows fast, right? Grows faster than like this. Right? Because when x is equal to 100, what's this equal to? 1,005, right? So, anyway, right? So you say, oh, that grows fast. But that doesn't grow anywhere near as fast as this. Okay? And this function comes up in certain, like when you're talking about, they talk about population growth. Like if you take a dish with bacteria in it, and you let it multiply, you have the population of the bacteria growing, and the number of bacteria that are there, the increase in the bacteria is proportional to the number of bacteria that are there. It's like if you look at two countries, some small country like, let's say, what's a small country? Sri Lanka, and a big country like India, and you look at, and suppose their populations are both growing, but if you look at the absolute amount of change in the population over, say, 10 years, suppose the populations double over 10 years. So when Sri Lanka doubles, what's the original population of Sri Lanka? Let's say it's 1 million. I don't know what it really is, but let's say it was, let's say it's 50 million. And suppose it doubles it in 10 years. So how much is it now? It's 100 million, right? So how much did it increase in absolute numbers? Not doubling, not percentage-wise. Percentage-wise it went up 100%, but I want to know the absolute increase. So it was 50 million, right? Okay, now let's look at India. Let's say India is 1 billion. Suppose that doubles in 10 years. So then how much is that? That's 2 billion. So how much did that increase in raw numbers? 1 billion. So the amount of growth is proportional to the amount that's there, right? So that's called exponential growth. That turns out to be exponential growth. That turns out to be guided by a function like this. Not exactly, maybe not this particular form of it, but a function like this, okay? Or if you take money, and that's where you're going to see it, guys. Shh. That's where you're going to see it. Particularly in your school studies, because you're business students. So if you put money in the bank and you let it and you get interest on that money, how much, you get interest on the money means what? You get a percent of how much is there, right? Just like when we say populations grow, they grow by percent of how much they had, right? So it's the same thing, right? They're growing, it's a percent of what's there. So that's also exponential growth, okay? And here's an interesting thing that I heard one time. They said that if you had took $1 at the time of Jesus Christ, okay, and you put it in the bank till now, and you got just a kind of normal interest rate, like, I don't know, whatever normal interest rate is in a bank, like 1%, 2%, whatever it is, how much would that money be worth now? So I'm trying to tell you how, I remember I was originally saying that this function grows maybe a lot. You might say that grows quickly, but when you see how exponential growth is, you'll be surprised. So how much do you think that money would be worth now? Well, of course you have no idea, but they say that it would be worth more than the amount of gold that you could fit in 1,000 Earths. Okay? So that shows you what exponential growth is compared to other functions' growth, right? So the point is that exponential growth is huge. Here's another way to illustrate that. Okay, what is g of 2? 4. So if I put in 2, I should get 4, right? Okay, what is g of 3? 8, right? 2 times 2 times 2, right? What is g of 4? 16, okay? Now, what is g of 100? Because we did f of 100, now let's think about g of 100. So what does that equal to? 2 to the 100, right? Now how big is that? Well, this is equal to 2 to the 4th to the 25th, isn't it? Right? Everybody agrees with that, right? But that is bigger than this, isn't it? Because 2 to the 4th is bigger than 10, right? So it's bigger than that, but how big is that number? 10 to the 25th. Right? That's a big number. That's a lot bigger than what we got for this function, which was 10,000. Right? This is 10 to the 25th. Right? And that's only when we put in 100. Right? 100 is not such a big number to put into that function. Right? So it's just, you can see that this is completely different than this. Even though the symbols are almost the same, right? If you look at them, you'd say, oh, you know, if you're not thinking about the math of them, just looking at them, you'd say, oh, it's almost the same thing, right? Maybe it's a little different. But it's not a little different, right? It's ridiculously different, right? So they're completely different functions, okay? So this is called an exponential function, and this is just called a quadratic function or a second degree function, whatever you want to call it. This is called an exponential function. So exponential function means that the variable is in the exponent. Okay, the variable is in the exponent. Okay, so I just wanted to point that out, actually, because I pointed it out in the other class and by mistake. So now we both classes have seen that. Okay, all right. Now let's go back to our regular discussion. Here, let's look at. Oops. Let's look at that. So don't let anybody tell you, oh, it's just exponential growth. It doesn't mean anything. Exponential growth means like you saw, right? Okay, does anybody have any questions before we start? Okay. Let me just say, I just want to call out a few names and see if you're here. So let me know if you're here. Rayimov Azizbek. Here or not here? Rayama Azizbek. Not here. Okay. Here. Los Jose. Los Jose is here? Yeah? Okay. Here. And Mirzaev Kamil. Mirzaev Kamil. And somebody named White. I think that was a mistake. And Myunggu Lee. Myunggu. Here? Okay. Okay. And Na Lumpun. Here? Okay. Good. And Shi Lin. Shi Lin. Here or not here? No. And Yukubov Sarbabek. Okay. And Shepat Asawanuchit. Okay. And Hilario Alex. Okay. And Krishnud Rakimov.